Greeting, Professor. Welcome to my video. My name is Darom. So today I'll be sharing how I'm working on the assignment on my boosting grade. In this video, I will explain step-by-step process of the exercise and the assignment. My goal is to make everything clear and easy to follow so you can understand how I approach the work. So let's get started to the part 1 of the improvement test. First, the question is, what is the number of the fifth selected employee if the first selected employee number is 5? First, we have to know the gap between employees. So the figure it out the part, we need to use this formula. K equal to total number of employee over number of employee we need. So there are 100 employee. We need to pick 15 employee. So after we put each value into the formula, we got K equal to 150 over 15, so the answer is 10. For this step, we need to select every 10 employee. And to make it short and easy, we can use the formula number of employee equal to first employee plus 1 minus 1 by and multiply by K. So as you can see, the fifth employee equal to 45. Moving on to question 2. In this problem, in step 1, we need to understand the problem. So the quality control manager want to check the percentage of defective light bulb. Each case has 30 light bulb. He will choose one case at random and check all the 30 light bulb in that case. So now I will explain the process and the reason before the quality control manager want to determine the percentage of the defective light bulb by taking the sample of 30 light bulb. Instead of selecting individual bulb from the different case, he randomly select one entire case, which contains 30 light bulb and check all the light bulb in that case. This method is called clustered random sampling because the cases are treated as cluster and one cluster case is randomly chosen to represent the group. Next is moving on to question 3. The question tells us that in the exam score follow a nominal bell-shaped distribution with a mean of 65 and a standard deviation of 10. We are asked to find the percentage of score between 35 and 95. And to solve this problem, first we have to figure out how far 35 and 95 are from the mean in terms of standard deviation. In order to do this, we need to use this formula. Number of standard deviation equal to value minus mean over standard deviation. For 35, after W put the value into the formula, we get a calculation of 35 minus 65 and divide by 10 equal to negative 3. So the 35 is 3 standard deviation below the mean. Also for 95, the calculation is 95 minus 65 and divide by 10 equal to 3. And that 95 is 3 standard deviation above the mean according to the empirical rule for nominal distribution. 95.7 of the data line within 3 standard deviation of the means. Since the range of 35 and 95 span exactly 3 standard deviation on both sides, this range includes 99.7 of the data. Therefore, the correct answer is A, 99.7 data. Moving on to question 4. It is about the level of measurement. So in statistics, there are 4 main level measurement are nominal, ordinal, interval, and ratio. This problem asks us to classify different variables into their respective level of measurement as it helps us better understand the nature of the data and how it can be used. In part A, the variable province like Phnom Penh and Kanda refer to the name of the place. These are just labels that identify different cities and there are no ranking or order among them. For example, Phnom Penh isn't more or less than Kanda. It's just the different name. The kind of data is called nominal because it's only name or label things without any order. For part B, is area. Area is the number tells us the size of the place. It has a true starting point at 0. If the area is 0, it means that there are no sides, which can also compare area like saying one area is twice as big as another. This means that the data ratio, because it is a measurable and the number have a real meaning, so the answer is ratio. Moreover, the number of household. It is countable value is start at 0. If there are no household, the value is 0. We also can compare this number, like saying one area has 3 times as many households as another, because the number are countable and start at 0. This data is also a ratio. However, for the tourism destination ranking like a popular, very popular, not very popular, and not popular at all. The variable show that the level of popularity like very popular or not popular at all. This is a clear order to this category. Very popular is higher than popular. And so, however, we can't measure the exact difference between them. So the answer is ordinal. For E, the number of supermarket is measured at the ratio level because it is a quantitative value representing a count. This level of measurement has an absolute zero, meaning that zero supermarket indicate the complete absence of supermarket, making the 0 point meaningful. Moving on to question 5. When you get this problem, you will given the data like this. It is not in order. So before you solving the problem, we have to sort the data into the smallest to the biggest. After sorting the number in order, it is more convenient to solve the whole exercise. So now we can calculate the mean mode median. First, the mean is average of the all number. To find this, we use the formula mean equal to sum of all data and divide by number of the data. So after put all the value into the formula, we got the mean is 155. Second, the mode is the number appear most often of the data set. By looking at the sort data, we can see that 155 appear at the fourth time, which is more than any other number. Therefore, the mode is 155. Next, we calculate the median, which is the middle number in the sort list. Since there are 10 variables, so it is an even number, and the median is the average of the fifth and the sixth. So the number which are both 155 and the median is 155 plus 155 and divide by 2 equal to 155. For time, we need to find the median of the lower half of the data. The lower half of the sort data is 150, 150, 150, 155, and 155, the fifth data. So we can find the middle value here by taking 5 plus 1 and divide by 2 equal to third number, which is 150. So the Q1 is 150. Finally, we calculate the third quartile, which is the median of the upper half and upper half of the data. The upper half is 155, 155, 160, 160, and 160. The middle value here is the third number, which is 160. 160 is here. So moving on to question 6. To calculate the mean of the given data, we use the formula for the mean of the frequency distribution. So the formula is mean equal to sigma of x multiplied by frequency and divided by sum of frequency, which equal to x1 multiplied by w1 plus x2 multiplied by x2 plus until xn wn. As you can see, after putting the value together, we got the answer is 8.3. Moving on to question 7. So the question, there are two box plots which in one for the shark and one for the seal. So the box and the whisker plot show that headset for shark and seal, the shark data is skew left, meaning that it spread more toward and the lower value because it has the left whisker is longer. The seal data is symmetric as the box and whisker are evenly distributed around the median. By the way, based on the box plot, we can see the median head size for shark is 7.25 and the seal it is 6.75. The range, which is the difference between the largest and the smallest value for the shark, range equal to 8.5 minus 5.75 equal to 2.25, and for the seal is 8 minus 5.75 equal to 2.75. Moreover, the interquartile range, which show the spread of the middle 50% of the data, is 1 for both sides. 7.5 minus 6.5 equal to 1, and the seal is 7.25 minus 6.25 equal to 1. Overall, the shark data is more variable because it has a larger range and show more spread toward the lower value compared to the seal data. Next, moving on to question 8. To solve this part, we need to find the percentage of the customer who spend between 6.65 and 7.65 at the restaurant. So looking at the histogram and find the number of the customer in the spreading range between 6.65 and 7.65. So the range are from 6.65 to 6.90, there are 18 customers spend this amount, and from 6.90 to 7.15, there are 31 customers spend this amount. From 7.15 to 7.40, these are the 13 customers spend this amount. From 7.40 to 7.65, there are 5 customers spend this amount. So now we just add all the customer together equal to 67 customers spend between 6.65 and 7.65. Next, to find the percentage, we have to divide the number of customers who spend in this range by total the number of customers 74, and then we multiply by 100. So 75 divided by 67 divided by 74 multiplied by 100 equal to 90.54%. This means that 90.54% of the customers spend between 6.65 and 7.65. For B, we need to find the percentage of the customer who spend at most 7.15, which means less than $7.15. To do this, we look at the histogram and focus on spending amount that are less than or equal to 7.15. This includes the spending range 6.40 minus 6.65, 6.65 minus 6.90, and 6.90 minus 7.15. From the histogram, we know that for customer spend between 6.40 and 6.65. Customers spend between 6.65 and 6.90, and 31 customers spend between 6.90 and 7.15. So we need to add this together and we get the total of 53 customers who spend at the most 7.15. To find the percentage, we need to divide the number of customers who spend the most 7.15 by the total number of the customer 74 and multiply by 100. This gives us 71.62 customer who spend at the most 7.15. Next, moving on to question 9. In this problem, is related to coefficient variation. It is a measure of relative variability and it is called as the ratio of the standard deviation to the mean expressed as percentage. The formula is COV equal to standard deviation multiplied by 100% and divided by mean. For project A, we have the mean equal to 12% and standard deviation 5%. Then we have to substitute into the formula. We got answer of COV equal to 71.67. For project B, we have mean equal to 16% and standard deviation 6.5%. And after we put the value all together, we got COV equal to 40.63% in response to the decision which project is better. So the lower of COV, the less variable project is. Since project B has the lower COV, the investor should choose project B. Moving on to question 10. So the question asks us to find the z-score, and the z-score will help to measure how many standard deviation a value is from the mean. The formula is z equal to x minus mean and divided by sample standard deviation. Based on the given data, we can use formula to find each element like mean and the sample deviation. First, we need to find the mean through its formula, which it is equal to the sum of all value and divided by the number of data. So we got mean equal to 127.1. Second, we just have to find the standard deviation. As you can see the formula of the standard deviation, we can substitute the value into the formula. We got sample standard deviation s equal 4.067. Last, we can find the z-score by substituting value z equal to 129 minus 127.1 and divide by 4.067, and the z-score is approximately 0.467. Moving on to question 11. Based on the problem, there are 40% that an agreement and it will be reached on both. There is a 50 percentage chance that an agreement will be reached on the salary and of the worker, and the 70% chance that there will be an agreement of the insurance benefits. So let's denote A as the probability that 50% of an agreement will be reached on the salary of the worker. So P of A equal to 0.5, B as the probability that 70% chance that will be an agreement on the insurance benefit. P of B equal to 0.7. Also P of A and B equal to 0.4. So based on the question, we need to find the probability of no agreement, no either issue. Before we can find the probability of no agreement on either issue, P prime of A or B, we need to find P of A or B equal to P of A plus B plus P of B and minus P of A and B, which is equal to 0.5 plus 0.7 minus 0.4 equal to 0.8. To find the probability of no agreement, no either issue, we use P prime of A or B, which equal to 1 minus P of A or B, which equal to 1 minus 0.8 equal to 0.2. So the probability no agreement, no either issue is 0.2. So for question 12, based on the problem, we have given some value to the data P of E given F. So to find this, we have to use the conditional probability formula P of E given F equal to P of E and F divided by P of E. First, we need to find the P of E and F equal to P of E plus P of F plus P of E or F, but P of F minus 1. P of F equal to 1 minus P of F prime minus 1 minus 0.4 equal to 0.6. After substitute all value, we got P of E and F equal to 0.2. Then we can find P of E given F equals 0.2 divided by 0.6 equal to 0.33. Next is question 13. Question 13. So this question asks us about among the female-owned business, what is the probability that there are less than 100 employees, which means PX smaller than 100. To solve this problem, we need to calculate the probability that a randomly chosen female-owned business has a fewer than 100 employees. First, we identify the total number of female-owned business, which is given as 898,000. Next, we focus on the business which is fewer than 100 employees. This include business with 1 to 4 employees, 500 500,000 for half of million 7,400 and business with 5 to 99 employees equal to 294,700. Adding this together is give us the total 802 100 business with fewer than 100 employees. To calculate the probability, we divide the number of business with fewer than 100 employees by the total number of female-owned business. So P equal X, P X smaller than 100 equal to 507,400 plus 294,700 divided by 809,800 equal to 0.9915. So this means that 99.15 of female-owned business have fewer than 100. So the probability is 0.9915. So for the last question is question 14. This problem involve calculate the expected value, the standard deviation of XXX based on the given probability distribution. The value of X are 30, 45, 60, and 75, with their corresponding probability being 0, 10, 0.10, 0.20, 0.30, and 0.40. So now let's, with part A, expect the value. The expected value or mean represent the average outcome of X when weighted by its probability. To find it, we use the formula expected value X bar equal to sigma of X multiplied by Px. This means that we multiply each value of X by its probability and then sum up the result, like 35 multiplied by 0.1 plus 45 multiplied by 0.2 and so on. So after we putting all the value together, we got the answer expected value equal to 60. Moving to another part about to find the standard deviation. So it helps to measure how much the value of X deviate from the mean, and the formula of the standard deviation is square root of sigma value of X minus expected value and put in square multiplied by Px. So after putting all together, the number together, we will get the final answer standard deviation equal to 15. For part C, find the probability of X falling within half a standard deviation above or below the mean. We need to calculate the range. We already know that the mean is 60 and the standard deviation is 15. The formula calculate the range is first 60 minus 0.5 multiplied by 15 equal to 52, and 60 plus 0.5 multiplied by 15 equal to 67.5. This means we are looking for probability of x being between 52.5 and 67.5. So now we need to check the x value in the table, and the only x value fall within the range is 60 from the table. The probability of x equal to 60 equal to 0.3. So the probability of x falling within the range mean plus or minus 0.5 is 30% or 0.30. This come to an end. Thank you.